Okay, so I'm at the point where people are complaining about simultaneous equations on a daily basis, even though I've heard people covering them like 5 times over, and this is driving me insane. So I'm just gonna put everybody out of their misery. Oh, thank you, OneDrive notification. Okay, I have a simultaneous equation x plus 3y equals 13 and x minus y equals 5. So when you're presented with a simultaneous equation like this, your goal is to find x and y. And you're given the facts that x plus 3y is 13, but it's also true that x minus y equals 5. So what can we do with this? Well, let's start with finding one of these. Let's say we want to find x. One simple way of doing that would just be add y to this equation, and then it becomes x equals y plus 5. And look at that, we found x. But we need to simplify this. We need to find out what y is. So let's say we want to find y. Okay, well, we know that x is y plus 5. So here we can turn this top equation into y plus 5 plus 3y equals 13, because x is y plus 5, so just substitute y plus 5 into x. And this equation will become 4y plus 5 equals 13. Now we subtract 5 from both sides and we get 4y equals 8. Now we divide by 4 and we get y equals 2. So we found y is 2. Now we already know that x is y plus 5. So if we substitute y is 2 into y, we get x is 2 plus 5. I'll give you some time to figure that out because that's very tricky. And yeah, it's x plus 7. So the answer we will get is x equals 2, y equals 7, which you could write in this notation if you wanted to be fancy, which I do because it reminds me of linear algebra, 2, 7. But don't worry about that, you've got the answer. The second way of solving a simultaneous linear equation, which I literally never use this method, but I'm going to teach it anyway, is instead of finding one of these variables in terms of another variable, which we did here, you can just get rid of one of the variables. So if 2x minus y is 7, then 4x minus 2y is 14. Obviously, we just multiply both sides by 2. The reason why we did that is because now the coefficient of x is the same in the top equation as in the bottom equation. So now we can subtract one equation from the other. So let's do 4x minus 2y equals 14, which is the top equation multiplied by 2. Let's subtract 4x plus y equals 23. When we do that, we're going to get rid of the 4x, and we're going to get minus 3y equals, what is this? We're subtracting 23 equals negative 9. So if negative 3y equals 9, divide both sides by negative 3, and we obtain y equals 3. Then we can substitute that back in as before. So if 2x minus y equals 7, then substitute in y equals 3, then 2x minus 3 equals 7, add 3 to both sides, then 2x equals 10, and divide both sides by 2, then x equals 5. So we have our answer, x equals 5, y equals 3, which we can write like this. And it might seem really weird, like why are we able to just subtract? Why can we multiply this equation by 2 and have it be the same? Well, the reason why you can multiply the equation by 2 and have it be the same is because you've multiplied both sides by 2. You've done the same thing to both sides. That's the basis of algebra. If you do the same thing to both sides of the equation, it's the same thing. As for subtracting the equations, I'm not going to get into why exactly that works, because that's really advanced for GCSE maths and nobody needs to know about Gauss's method and the linear combination lemma, but it does work because linear algebra reasons, which I love, but I will not get into yet. Okay, I'll walk through the rest of the problems just for the sake of it. Let's use the substitution method this time. So if x plus y equals 2, then x equals 2 minus y. And if x equals 2 minus y, then x plus 2y equals 6 can be written as 2 minus y plus 2y equals 6, which we can simplify to 2 minus y equals 6. Wait, no. 2 plus y equals 6. Whoops. So therefore, subtract 2 from both sides and we obtain y equals 4. Then if y equals 4 and x is 2 minus y, substitute in y equals 4 and we obtain x equals 2 minus 4, so x equals negative 2. So x equals negative 2, y equals 4, and let's write that in column notation again because I love linear algebra. Okay, so the coefficient of y is the same in both equations. We have 2y. Well, it's not technically the same because here it's negative 2, but they're both the same whole number, just with a different sign. So that makes things easy for us if we want to use the elimination method instead of this substitution method. So let's take our first equation, 3x minus 2y equals 16, and let's add 2x plus 2y equals 14. And if we do that, then negative 2y plus 2y is 0. So the y terms will cancel out. And then 3x plus 2x is 5x. And then 16 plus 14 is 30. So we obtain 5x equals 30. Divide both sides by 5 and we obtain x equals 6. Now let's substitute x equals 6 into 2x plus 2y equals 14. We will get 12 plus 2y equals 14. Subtract 12 from both sides and we get 2y equals 2. Divide 2 from both sides. Divide both sides by 2 and we get y equals 1. So x equals 6, y equals 1. 6, 1. And that is how you solve simultaneous linear equations. How you check you've got it right. You can substitute the values for x or y back into one of the original simultaneous equations. So if I'm not confident that x equals 6, y equals 1 is the solution, then I can take one of these equations and substitute the answer back in. So 3x minus 2y equals 16, let's use that. So if x equals 6, y equals 1 is the solution, then that means that 3 of 6 minus 2 of 1 will equal 16. We just substituted these back in to see if this actually satisfies these equations that we're hoping to find our answer to. So 3 of 6 is 18 minus 2 of 1 is 1, which does equal 16. Go check for yourself with a calculator. 18 minus 2 is 16. And if I want to be extra confident, I can check this with the second simultaneous equation, with the second equation. So 2x plus 2y equals 14. Then that means 2 of 6 because we set x equal to 6 as our solution. Plus 2 of 1 because we set y equal to 1 as our solution. Equals 14, and this is 12 plus 2 equals 14, which indeed it does. Again, go check for yourself with a calculator because 12 plus 2 is very difficult. And that is how you solve simultaneous linear equations and check your answer so that you can be confident it's correct. But importantly, keep in mind for the elimination method, you can just add and subtract these equations from each other and it sort of just works. Don't ask me this was you can multiply them too. You can add and subtract the equations from each other, and you can multiply them by any scalar, so by any single value, as long as you're multiplying the coefficient of every variable and constant by the same basic scalar real value. It works because of something called Gauss's method, probably, or is it the linear combination lemma? I'm pretty sure it's one of the two. It's something adjacent to the linear combination lemma, but that's linear algebra that you don't need to know. Just understand you can add and subtract these from each other, and you can multiply them as long as you're not multiplying them by each other. You're multiplying them by just a basic number. The equation will still have the same value. And you can get really crazy and wild with that, and I encourage you to, because it's very fun and you're probably going to impress your maths teacher, especially if you tell your maths teacher about the linear combination lemma. Just don't pretend to know what it is because you will get clowned on.